Hi, this is lesson 4.1 in geometry, and we are going to be learning how to recognize congruent figures and their corresponding parts. You have done this before if you've ever worked a puzzle. So look at this puzzle. There are 3 pieces that are missing, and to figure out which pieces would fit, you would have to find a shape that is congruent to the missing piece. So if you look at spot A here, to figure out which puzzle piece would fit, you'd have to have all the corresponding parts be the same exact side. And if you look at puzzle piece 1, I think that you would see that that would fit in. You would slide right in. So to be congruent, all of the corresponding sides have to be the same, and it has to be the same shape. So let's look at some definitions here before we get too much further. Corresponding, remembers, means having the same characteristics or matching something else. And then, this is a biggie, congruent polygon. So this is a really important definition for this section. 2 polygons are congruent if they are the same size and the same shape. That is, if their corresponding angles and sides are equal in measure. Okay, so corresponding angles, all the corresponding sides have to be equal in measure. And when you have congruent polygons, corresponding vertices are listed in the same order. So here is an example. We have 2 4-sided polygons. They're the same size, same shape. We would call them quadrilaterals because there are 4 sides. And because it tells us that quadrilateral ABCD is congruent to quadrilateral EFGH, what I know is that the measure of angle A and E are the same. Those are congruent. And then because we have B next, that is going to be congruent to F. So angle B and angle F are congruent. And then next in the name, we have angle C. I'll put 3 marks there. That is going to be congruent to the 3rd letter, which would be angle G. And then lastly, angle H and angle D are congruent. It's kind of thick when I try to do 4 lines there, but those 4 go together. Now, also when you name the congruent angles and the congruent sides, you put the corresponding segments, endpoints in the same order. Like if you are referring to this as AB, and it's going to be congruent to this side, which is EF. Now notice A is first and E is first because they correspond in the name. And they are the same size angles. And angle B and F are the same size angles, so they are both second, all right? And then you would have AD congruent to EF, segment AD, congruent to segment AD, congruent to EH, I should say. Did I say F? EH? How's that? Or you could say DA and HE. That would work too. And then if you're referring to the next side right here, if we call this segment DC, then we're going to call this segment HG because the D comes first, so then the H would come first because those are the same size. And in order to be congruent, all the corresponding angles have to be congruent, all the corresponding segments have to be congruent. Let's just review polygons real quick. You have to know these names, so if you don't have them memorized, you do need to study those. So if you have a 3-sided polygon, and by the way, a polygon is a figure that is made up of line segments, and it's a closed figure. If you have 3 sides, that's a triangle. 4 sides, like I said earlier, is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. So the X helps me remember what that one is because there's this X in 6. And then 7 sides, that's the one that I have a hard time remembering. I had to study that one. Heptagon. Heptagon. 8 sides is an octagon. 9 sides is called a nonagon. 10 sides is called a decagon. And 12 sides, that's a fun one. It's a dodecagon. And then anything else, you would say the number and then like a gon. So if it's 13 sides, it would be a 13gon. If it's 11 sides, it would be an 11gon. Okay. And there are, if you study other books, there are more names, I think, than what our book gives, but we'll just go with that. Okay, so now let's talk again about the definition of a triangle. A triangle is a polygon with 3 sides. A triangle with vertices A, B, and C is called triangle ABC, or you can use a little symbol of a triangle and call it triangle ABC that way. That's how we name a triangle. Now we can classify a triangle by the types of sides and also by the angles in it. So if you have a triangle with no congruent sides, it is called scalene. No congruent sides, it is called scalene, and that's a vocabulary you will need to know, vocabulary word that you will need to know. An isosceles triangle has 2 congruent sides. So some books say exactly 2, but it doesn't have to be exactly 2, I guess. So 2 congruent sides. That's isosceles, 2 congruent sides. And if all of the sides are congruent, it is called equilateral. Equilateral. So we have isosceles if 2 sides are congruent, and equilateral if 3 sides are congruent. All right, next we can classify a triangle by the types of angles. If it has a right angle, it's called a right triangle. If it has an obtuse angle, it's called an obtuse triangle. And if all of the angles are acute, it's called an acute triangle. The last word that you need to know, is really important, is an equiangular. That is when all the angles are congruent. So let's just do a little quiz here and see if you remember in the last chapter, if all of the angles are congruent, what would the measure of each be? Well, hopefully you remember that the measures in a triangle add up to 180. So if they are all equal, you would take 180 divided by 3, and you would find that each of them would be 60 degrees. Okay, so again, equilateral is when the sides are congruent. Equiangular is when the angles are congruent. All right, it says next, write a congruence statement for the triangles. Identify all pairs of congruent corresponding parts. All right, so we'll call the first triangle, triangle, let's go with JKL. All right, and now we'll notice we have 3 sets of congruent angles, and we look at the number of little tick marks, I call them. And then we look at the sides. We have 3 sets of congruent sides. So that means we have congruent triangles. So when we name the next one, we just have to make sure that we have corresponding angles in the same location. So angle J is this one right here, and that has 3 little marks. So in the other triangle, that corresponds to angle T because that has 3 little marks. And then we go to K, which has 1 mark, so we're going to go to S. And then lastly, we will go to L is going to correspond to R. So triangle JKL is congruent to triangle TSR. So you just have to make sure, again, that the corresponding equal angles are in the same order, okay? So next what we have to do is identify all the congruent angles. So first of all, we'll do the angles. Angle J is congruent to angle T. Angle K is congruent to angle S, and angle L is congruent to angle R. Okay, so you list the 3 angle pairs that are congruent. Next, we're going to list the sides, corresponding sides. So if we start with segment JK, so I can look at the number of ticks. That's 3 ticks to 1 tick. Okay, then if I look over here, 3 ticks to 1 tick would be T to S. Okay, and now we'll just keep going this direction. So KL, segment KL, is congruent. Now that's 1 mark to 2 marks. So 1 mark to 2 marks would be S to R. And that's a segment. And then lastly, the longest side would be LJ, segment LJ. Okay, and that's 2 marks to 3. And so 2 marks to 3 would be RT, segment RT. So in order to show that you have congruent triangles, you have to show all 3 sets of angles are congruent and all 3 sets of sides are congruent. All right, let's solve some problems using this. It says in the diagram, DEFG is congruent to SPRQ. So when you see that, what that would mean is angle D would be congruent to angle M. So angle D, right away, I can fill in everything I know. Angle D and D and S are the same. So these two are the same. And so if this angle D is 102, I know that S is 102. So fill in everything you know. And angle E and angle P are congruent because they're second. Okay, so angle E is this one, and angle P is this one. And I don't know anything about those two angles, so we just won't write anything. Next, we know angle F and Q are congruent to each other. So F is this one, Q is this one. So we know that this is equal to 68. And it is also equal to 6y plus x. So we're going to be able to use that 68 to solve that. And then lastly, angle G, which is this one, is congruent to angle R, which is this one. So you know that this is 64. Now it says find the value of x. Well, let's see here. And then it says find the value of y. In this one right here, there is an x and a y. So I can't solve that just yet. But I know that segment DE is going to be congruent to SP. Okay, so then this is 8 feet. So I can fill that in. Okay, these two go together. And I also know that segment FG, this one, is congruent to segment FGQR. So those are like the two longer sides. And if this is 12, this one is 12. So now I know that 2x minus 4 is equal to 12. I can make an equation. So first I'll just solve that by adding 4 to each side. And then divide by 2. So x equals 8. Now I have one of the answers. X is equal to 8. Now to figure out what this to y is, I know that 6y plus x equals 68. And since I found out that x is 8, I'm going to substitute that in. So 6y plus 8 equals 68. So I had to do some figuring on this problem. But you always want to start by filling in everything you know, by looking at those corresponding parts. So y equals 10. There's my answer, my second answer. Y equals 10. The next question says the wings of an SR-71 Blackbird aircraft suggest congruent triangles. What is the measure of angle D? Well, if they're congruent, the corresponding parts are going to be congruent also. So we have, let's see, these angles are both 30. These would both be, what is the measure of angle D? Well, let's see. This one would have to be 75. Okay, if this flipped over, angle C and F would be the same size. And so you have two of the measures. And so to find the third, we would add the first two together and subtract from 180. So 75 plus 30 is 105. And then we would take 180 minus 105 and get 75. So this angle right here would have to be 75. All right, the next one says, are the triangles to the left congruent? Well, in order to be congruent, remember all the corresponding sides have to be the same length and all the corresponding angles have to be. So we have, let's see, angle B and angle D are congruent. And we have that angle A is congruent to angle E. And what do we know about this angle and this angle? Well, those are congruent because they are vertical angles. Let me get a different pen here. So I'm going to mark those congruent because of vertical angles. Now, when I name those angles, I can't just say angle C because there are all kinds of angles located right here, right? So I need to use 3 letters. So we'll say angle ACB is congruent to angle. Okay, angle A, I use that first. And so I went angle ACB. So when I name this angle over here, I have to start with the angle that corresponds to angle A, which would be E. So that would be angle ECD. So those angles are congruent because of vertical angles. Since angles are vertical angles, or I could have just said vertical angles are congruent. Okay, so now we have 3 sets of congruent angles. Well, we also know then that segment AB is congruent to segment, so this one is congruent to this one, ED. Okay, that's given. And we know that this segment is congruent to this one because they're both 4. So we could say BC is congruent, segment BC is congruent to segment DC. And again, the B has 2 ticks and the D has 2 ticks. So I put those first in the name. And then lastly, segment AC is congruent to segment EC. So because you have 3 sets of angles congruent, 3 sets of sides congruent, we can say triangle ACB is congruent to triangle ECD. And the reason would be the definition of congruent polygons, which says if all the corresponding sides and all the corresponding angles are congruent, then the polygon is congruent. Now, the third angles theorem says that if 2 angles of one triangle are congruent to 2 angles of another, then the third angles are also congruent. So if angle A and angle D are congruent, and angle B and angle C are congruent, what this says, so if you know 2 sets are congruent in each, then the third angles are also congruent. Let me just show you why that would work. Let's say that this is 80, and this is 80, and these are the same. Let's say that those are both, let's see, 30, okay, and 30. Well, looking at just the first triangle, if this is 80 and that's 30, that's 110. That would mean this one would have to be 70. Go over here, if you have an 80-degree angle and a 30-degree angle, again, that's 110, which would mean this would have to be 70. So if you know 2 of them are congruent, then the third ones will be congruent. So again, that's the third angles theorem. And there is a lovely proof here. We are going to get back into proofs in this section, but they're fun ones. You're going to like these. So if you start out with 2 sets of angles congruent, A and D, B and E, we have to prove that the third ones are congruent. So to prove it, you write down your givens. And if angle A and D are congruent, that means the measures are equal. And if B and E are congruent, those measures are equal. That's the definition of congruent. If they're congruent, they're equal. Now we know that in each triangle that the 3 angles, angle A, the measure of angle B, the measure of angle C adds up to 180. And in the second triangle, the 3 measures add up to 180. And that's the triangle sum theorem, that the sum of the 3 angles in a triangle is always equal to 180. So since both of these sums equal 180, you can say those sums equal each other. Remember, that's the transitive property, or they use substitution here. I like transitive better for a reason. Well, then let's look and see what happened. If you look, they changed the A to a D, the measure of angle A to D. They changed the measure of angle B to angle E, and then everything else stayed the same. Well, they did that because angle A is equal to the measure of angle D, and the measure of angle B is equal to the measure of angle E, so they use substitution. Well, and then the next step, they subtracted the measure of angle D from both sides. They subtracted the measure of angle E from both sides, and they're left with the measure of angle C equals the measure of angle F, which is the subtraction property. And if the segments, or if the angles are equal, that means that they are congruent. That's the definition of congruent angles. So that's the proof of it. All right, almost done here. So we have this angle and this angle are congruent because they both have one tick mark. So what you want to do is just put fill in the missing angle, and we have to find x. Well, looking at this, we know that this is 90 and this is 65, and so we'll add those together. That would give us 155 total, right? And then we would subtract from 180 to find out what x is. So that would be 25. So this is 25 degrees. Let's look at the next one. Let's see here. First of all, fill in everything you know. Let's see, angle B and D are the same, so these are both 60. You have a few different ways you could solve this. Here you have 2 marks. Over here you have 2 marks on angle E, so that is 70. So if you need to find x, what you could do is you could say, okay, I know 3 angles here. Add those together, set them equal to 180. And then remember, we always combine like terms. So that's 130 equals 180. Scroll down a little bit, subtract 130. And then divide by 2. So x equals 25. So that's one way of doing it. The other way you could do it is if you know that these 2 angles, the 60 and the 70, are the same as the 60 and the 70 over here, you would know that angle A and angle F have to be the same by the third angles theorem. So you could just calculate what angle A is. If this is 60 and 70, that's 130. And then 180 minus 130 is 50. That means that this angle has to be 50, which means this angle has to be 50. So 2x equals 50, x equals 25. So that's really 2 different ways you could do that problem. All right, now what we're going to do is we have to do a little proof here. We are given that LM is congruent to LO. So LM is congruent to LO. We're given that segment MN is congruent to segment ON. And then we are given that the measure of angle M and O are congruent, and the measure of angle ML O is congruent to, let's see, what are we given? MLN. MLN. Let me use my red pen here. MLN is congruent to angle OLN. So these 2 are congruent. So we have to prove that the triangles are congruent, which remember, all 3 sets of angles have to be congruent and all 3 sets of sides. So first, this isn't going to be bad, write your givens. I'll put it all in one step. So that is given. Now let's first look at the side that we're not given. Okay, that would be LN and LN. So if you flipped this over right here, the M would land on the O, right? So LN, segment LN in the top triangle is congruent to segment LN in the bottom triangle because they're the same side. So that is the reflexive property. Remember when we learned that in chapter 2? So it's the same thing, congruent to itself. That's reflexive. So now we have 3 sets of sides congruent. Let me mark that. You always want to mark it. When you make a statement that you have a side congruent to another side, mark it. And then we're missing one more angle. That would be this angle right here, angle MNL. And that is going to be congruent to angle ONL. Why would that be? Let's think about what we've learned. Well, we know that two angles in one triangle are congruent to two angles in the other. And then from the third angles theorem, then we know that the third angles would have to be congruent to each other. So the reason would be the third angles theorem. And now we've listed all three sets of sides congruent, corresponding sides congruent, all three sets of corresponding angles congruent. And so in our last step then, we can say that triangle LMN is congruent to triangle LON. And that is because of the definition of congruent triangles. Now it's kind of a lot to have to list all three sets. So the good news is we're going to be learning some shortcuts. We have actually a total of 6 shortcuts in proving that triangles are congruent. So we'll be doing that in these next few sections. All right, so let's just go through a few problems that are going to be in your homework today. And the first one says, given triangle QXR is congruent to triangle NYC. Now, there are a couple ways you can do this. One way that I like to do it that really helps a lot is to just draw 2 triangles and label them. So this, if we call this one QXR, since I started with Q in the name, okay, I'm going to start in this bottom corner with N because the other triangle Q and N correspond. So NYC. So QXR, NYC. So then when we look at what corresponds, QX is this side. That would correspond to NY, segment NY. And you have to have corresponding parts together. The other thing you can do without drawing a picture is just look and say, okay, QX would be the first 2 letters here. The first 2 letters here would be NY, segment NY. And then angle Y, which one does that correspond to? Angle Y is the top one. It would correspond to angle X. Or you can just say Y is the center here and X is the center here. So that's all you do for that. The next one is triangle BAT. So again, I like to draw it out. I'm very visual. It helps a lot. And then we'll draw the other triangle. So BAT, and this will be FOR. Okay, so we started in the lower left-hand corner. BAT, FOR. So TA, so we're starting with T, going up to A. So over here, that would correspond to or be congruent to RO, segment RO. So TA in the name and RO go together in the name. And then angle R is this one. That would correspond to angle T or be congruent to angle T. And we know they're congruent because the triangles are congruent. So corresponding angles are congruent. The next one, we have 4 letters, which means you have a quadrilateral. So BAND, BAND. So this time I started in the upper left-hand corner. So in the next one, I'll start in the upper left-hand corner, LUCK. So angle U corresponds to angle A. Again, U is the second letter, A is the second letter. DB, so starting at D, going up to B, would correspond to segment, or be congruent to segment KL. Can correspond and congruent, I should say. And then lastly, now here we named it in a different way, just with different letters. So starting with N, going to D, and then B to A. So here we would start with C, and go to K, and then L and U. So started with N and then went to D. So ND, CK, and then BA and LU. Let's see, I think, let's do number 4 together too. In triangle MAP and triangle TIE, it tells you which angles are congruent. What is the relationship between M and T? So first of all, draw these little triangles. MAP and TIE. Okay, again, draw the little triangles and make sure that the corresponding parts of the name are in corresponding positions. Angle A is congruent to angle I. Angle P is congruent to angle E. Well, we know that if those two angles are congruent, that the third angles are also congruent, M and T, because of the third angle congruence theorem. So we would be able to say that this is congruent to this. Angle M and angle T are congruent. And then it says if the measure of angle A is 52, well, right away, if it tells you that angle A is 52, you know that the measure of angle I is 52, so you can fill that in. And if the measure of angle P is 36, okay, so I'm going to fill that in. And if this is P and E are congruent, it told us, so you can fill it in over here. What is the measure of angle T? Well, we would add those two together and subtract from 180 to find the measure of angle T. So that's how you do this lesson, and these are the problems that I want you to do for your assignment. Thanks for watching.